Welcome to LabMinutes.com. In this video, we will look at another way of achieving DMVPN redundancy with the feature called NHS Cluster and Recovery Backup that was made available in the 15.1.2t code. So instead of relying on your routing protocol to perform the failover, as you might have seen in the do-hub do-cloud or do-hub single cloud designs, with this particular features you have a concept of NHS cluster. So within each of your data center, you might have one or more cluster, and within the cluster you have a member routers that's acting as NHS. So when the spoke needs to connect to each data center or each cluster, it will build one or more connections to the routers in those clusters. So when the primary router in that cluster fail, it will be able to back up or fail over to the backup NHRP routers to reach the NHRP services. So the way to do that, you control who's being a primary or backup by the mean of priority values. So the lower the priority that you assign to a router, the more likely the spoke will register to it, and the one with the higher priority value will just sitting there waiting and be a backup router. So in our lab here, we have router R1 and R2. That's configured as the DMVPN headends, with R1 having a NHS priority 1. So it's going to be acting as a primary NHS router, and R2 having an NHS priority 2, and it's going to be acting as a backup NHS router. We have our R3 here as a spoke router, and the first is going to register to R1, and we're going to see in our lab here when the failover happens, it's going to switch and register to R2. So that's how the redundancy is achieved. So let's walk through our config. So all of three routers have been partially pre-configured. With the configuration on R1, there's really no change. There's no additional configuration to switch on these features because it's totally control of the spoke that's going to basically decide which of the NHS server is going to register to first. So if you look at the config on our R1, just to show you, it's a I would assume you are familiar with this config already, and it's just a standard NHRP DMVPN configuration, and the same goes with R2. With both router being on the same DMVPN cloud with the NHRP network ID 1. And each has the IPsec turned on to complete the DMVPN. And now on R3, if you look at the config, it also has the basic configuration in place, except the static NHRP server mapping that we gonna put in a second. So right now, if you do show IP NHRP, you can see there's currently no mapping, so R3 has no idea where the NHRP server is located. So the first part of our configuration is to define the NHRP map statement. So here we have two NHS routers, R1 and R2, that we can use. So we first get into the tunnel interface and then define IP NHRP map. Well, before we do that, let me keep the tunnel interface shut down for now. And once we complete the configuration, we'll bring that back up. So we have an NHRP IP map. We're going to configure the R1 first, having the tunnel IP 1.1 and the physical IP of 4.1. Next, we're going to do IP NHRP map multicast to 4.1, still dealing with R1 here. And next, we're going to define the NHS of R1 with the NHRP IP of 192.168.1.1. And here instead of, usually you would press enter right here, but we're going to give it a priority. As you can see, the option priority, and it's between 0 and 255, and if you take a note here, 0 is the highest priority, so we're going to give it 1, and we're going to define it as a cluster number 1. Next, we're going to repeat the exact same thing for NHS on router 2. So 1.2 map to 172.16.4.5. NHRP map multicast 192.16.4.5. NHRP NHS 192.168.1.2. Here we're going to give it a lower priority with the higher number 2 and putting them in the same cluster, cluster 1. Okay, there's a few more options that we can do. If you do NHS and question mark, we can configure the cluster number 1, and you can define what's the maximum connections that the spoke is allowed to make concurrently. We're going to start it off with just one connection, and we'll change that in a little bit later and see how that works. Next, we're going to do IP and NHRP NHS, and there's a option fallback. So when the spoke fails over to the backup router and the primary router recovers, this is basically the amount of time it would take for the spoke to switch back to the primary router. So here we're just going to give it 5 seconds. Okay. Let's take a look at the tunnel 1 interface. Configuration, all of those are in place. And you can see here all of the configuration for this particular features is done on the spoke router. So spoke is the one that makes a decision of which NHS router it's going to register to. So now, with all those ready, we're going to no shut and bring up the tunnel interface. Okay, so you can see tunnel 1 state changed to up, and then we have a neighbor, EIGRP neighbor with the 1.1 or R1. So although we have 2 NHRP headends configured, we only have one neighborship that comes up, and the reason being, if you do show IP NHRP, we have 2 static mapping that we define, but if you look at the second one, it said no socket, so it doesn't really make a connection to the backup NHS. And if you do show IP NHRP NHS redundancy, and this is where it says right here that it's waiting to make a connection to the second NHS router, which is 1.2. While the first one is R being responding, so it knows that R1 is responding and E is expecting. That means everything is up and running right now. And if you look at show IP EIGRP neighbor, you can see there's only one neighbor on the tunnel 1. If you show IP route EIGRP, is also receiving route from 1.1. Okay, so next we're going to try to perform the failover, and we're going to do that by shutting down the interface on R1 that connects to the switch, and that would be this particular port right here, which is port FAST01, and switch 1 that connects to the R1 interface. But before we do that, we're going to do some pings. So we're going to ping the switch loopback that sits in the back here, 172.16.0.1 from R3. sourcing from R3 loopback 0, and you're just gonna do a large repeats. Okay, now that's going. Get into the switch one and then shut that interface down. So now R1 or R3 has lost connectivity to R1. So let's see how long it takes for R3 to fail over to R2. Okay, so now the hold time expired for EIGRP. Okay, and now we are back up, and just right at the same time, you can see there's a adjacency that comes up with the EIGRP neighbor to the 1.2, which is R2. So if we repeat the same sets of show commands, show IP NHRP, now the mapping for R2 no longer said no socket. Now that entry is being active. If we do show IP NHRP, NHS redundancy again, now you can see 1.2 current state is RE, which is responding expecting, and it's up and running, while the 1.1 is now just becoming expecting and is no longer responding. If you look at the EIGRP neighbor, now we have a single neighbor, but instead of being R1, it is R2. And we are still learning the same sets of EIGRP routes, but this time it's coming from 1.2 instead of 1.1. Okay, so that's how the failover is achieved. When the spoke detects that its primary NHS server is down, it will switch and register to the backup. So it will basically only peer EIGRP to one of the server one at a time with the command, just to show you right here, maximum connection being 1, so it will only connect to one of the NHS one at a time. So now let's see what happens if we increase that number to 2. Also, before we do that, just to show you from the switch perspective, it's learning the route loopback 0 of R3, which is 172.16.33, from R2 only. Okay, let's bring R1 back just to show you how the failback occurs. Okay, so I'm going to do no shut on the interface. Now we're on R3. Let's give it a few seconds. Okay, the neighborship to R1 has recovered. Okay, and the neighborship to R2 has gone down. Okay, since R1 has the higher priority, it's switched back, the spoke switched back to the primary router once it detects that the primary has recovered. So here that's why it connects back to R1. And if we do show IP NHRP, and that time, the amount of time is determined by the fallback command that we put under the tunnel interface. Now we do IP NHRP NHS redundancy, and everything went back to the way it was. Okay, so now we're going to go ahead and modify our maximum connection on the tunnel interface right there to 2. and let's see what happens. So as soon as you do that, the neighbor shipped to R2 EIGRP came up, and we do show IP EIGRP neighbor. Now you can see there are two concurrent neighbor, since we allowed the max connections to be 2. And if you look at the NHS redundancy, both R1 and R2 shows up as responding and expecting. So spoke R3 concurrently talks to R1 and R2. You can see right here registering and being up, count is 2. So as far as the routing table is concerned, we are now receiving the exact same routes from 2 different neighbors. And if we go back to the switch, we are seeing the exact same thing. So switch learns the R3 loopback routes from both R1 and R2. So essentially we are just back to the way we had it with do DMVPN hub and single cloud. Okay, so where we have a single cloud, but R3 registered to both R1 and R2. So this is essentially just that. Okay, so let's change that back to 1. Okay, so for this particular features, there's some pros and cons that you might have realized. So the pros for this would be you're not dealing with routing failover. Your routing table looks much cleaner because you no longer has a duplicate routes given your max connection just 1. So you would not have a routes you would be learning for multiple neighbors, and you don't have to worry about manipulating the EIGRP or your routing protocol metrics to make sure that the routing or your traffic is symmetrical. So by having your spoke register to just 1 hub, it's pretty much solved that problem for you. So the routing will always be symmetrical. So that is a benefit of this particular feature. But the downsides would be the failover time might not be as fast as the routing failover, because it might take a couple seconds for the spokes to realize that the primary NHS server is no longer available and needs to switch over to the backup. Well, if you compare that to the routing failover, it might be much faster. But if the failover time is acceptable to you, this particular design or feature might be a better option. Just like I said, it keeps your routing simple. Okay, again we're back to the way we were, and you are only dealing with 1 copy of the routes, and this is true bidirectionally. Right here. So here you go. This is just another option for you to consider for configuring redundancy for your DMVPN deployment. And again, just to reiterate, this particular feature is available starting at iOS version 15.1.2t. So if your router is running an older code, you would not see the commands that we have tried in this lab. Okay, thank you for watching LabMinutes.com. I'll see you guys in the next video.